Hi everyone, my name is Shubhankar Parashar and in this video we will be discussing about area of figures and some important questions which is a subpart of mensuration. Firstly, what actually mensuration is? Mensuration is a division of mathematics that studies geometric figures, calculations and its parameters such as area, length, volume, lateral surface area, etc. It outlines the principle of calculation and discusses all the essential equations and properties of various geometric shapes and figures. You might be wondering, why is there a need to study mensuration? Where is mensuration used in our daily life? So, mensuration is used to calculate capacity of big hall, container, tubes and many more things. It is used in making a needle to building a big skyscraper. As you can see in the figure, it is a beaker which we usually see in our chemistry labs. It is marked as 500 ml. How it is calculated? Yes, using mensuration. Starting from the basic, we will be learning about units. Basic units which are used in mensuration are length, millimeter, centimeter, meter, kilometer. For capacity we use milliliter, liter. For mass we usually use gram or kilogram. Unit conversions. Point to remember. To convert bigger units into a smaller unit, we always have to multiply. To convert a smaller unit to a bigger unit, we have to divide. Some unit conversions are given. In this you have to remember the conversion of millimeter to centimeter, and centimeter to meter, and meter to kilometer. So moving on to area of 2D figures, we all know area of rectangle and area of square. Area of rectangle is equals to length into breadth. Area of square is equals to side square. Area of a triangle is equals to half base into height, and area of parallelogram is twice the area of a triangle. As we can see in the figure, if we draw a diagonal in a parallelogram, there are two triangles with equal base and same height. So area of parallelogram will be base into height. Area of a trapezium is given by half sum of parallel sides into height, and we all know area of a circle is equal to pi r square, and area of a sector is equal to theta upon 360 into pi r square when theta is in degrees. If theta is in radians, then the formula will be theta upon 2 pi into pi r square. Moving on to area of 3D figures. Cylinder. Curved surface area of a cylinder is equal to circumference of the base into height, which will be equal to 2 pi r into h. Total surface area is equal to curved surface area plus area of the base, which will be equal to 2 pi r h plus 2 pi r square. Cone. Curved surface area of a cone is equal to pi r l, where r is the radius of the cone and l is the slant height. Slant height is this height, not the perpendicular one. Total surface area will be equal to pi r l plus pi r square, and pi r square is the area of the base of the cone. Area of sphere is equal to 4 pi r square, and half of this will be the curved surface area of hemisphere, which will be equal to 2 pi r square. So the total surface area of a hemisphere will be equal to 2 pi r square plus pi r square, which will be equal to 3 pi r square, and in this pi r square is the area of the base of hemisphere. Moving on to the important questions. First question. The base area of a box of stickers is 85 cm square. How many of these boxes will fit in one layer of a palette of area 1.36 meter square? In this question, we have to find out the number of boxes which will fit on one layer of palette, like this. So first thing which we have to do is to convert area of palette, which is given in meter square, into centimeter square. So we will be converting it by multiplying by 10,000. So the number of boxes that can fit will be equal to area of palette upon area of a single box, which on calculating will give 160 boxes. Moving on to the next question, we have to find out the area of the given figure. In this figure you can see there are 3 rectangles, this one, second and third, and 1 triangle. In this we have a rectangle of side 3 into 2 and rectangle of side 6 into 2, which will be given by 4 minus 2 is equals to 2. Alright, and rectangle of side 2 into 2 and triangle of base, which will be equal to 7 minus 3 minus 2, which will be equal to 2, and height 2. So the total area of the figure will be equal to area of all the rectangles plus area of the base, area of the triangle, which will be equal to 24 units square. Moving on to the next question. In this question we have to find out the area of the given figure. In this figure you can see that there is a hemisphere of radius 2 units, a cylinder of radius 2 units and height 5 units, and a cone of radius 2 units and slant height 3 units. So the total area of the figure will be the CSA of all the 3 shapes, which will be equal to 2 pi r square for hemisphere, 2 pi r h for cylinder, and pi r l for cone. Moving on to the next question. In this question we have to find out the area of shaded region. This is one of the most important questions which is usually asked for mensuration. In the given figure you can see that there is a big semicircle of diameter 9 cm and a complete circle of diameter 4.5 cm and small semicircles in which 2 are in the larger one semicircle and 1 is outside it. So area of the shaded region will be area of largest semicircle plus area of one semicircle minus twice the area of semicircle minus area of the given complete circle, which on calculating will be equal to 27 by 4 pi centimeter square. Next question. In this question we have to find out the surface area of the given figure. This is an easy question, but you have to understand the concept of rings. In this, the radius of cone is larger than the radius of cylinder, so it forms a ring like this. And the area of a ring is given by the area of larger circle minus the area of smaller circle. So in this question, area of the complete figure will be equal to CSA of cone plus CSA of cylinder plus area of one base plus area of the ring. Next question. Find the surface area of the figure. In the given figure, we have curved surface area of cylinder, 2 semicircles of radius 5 meter and a rectangle of length 15 meter and breadth 10 meter. This is actually a half cylinder. So the surface area of a half cylinder will be equal to length into breadth plus pi r square plus 2 pi r h. So what if height and radius of a cone is given? Then how will you be calculating the curved surface area of a cone? There are many questions in which only 2 out of radius, height or slant height is given. In such cases, you need to calculate the third one using the formula L square is equals to h square plus r square, which can be easily derived using Pythagoras theorem if we consider cone as a 2D figure. With that, we have reached the end of the video. So for a quick recap, we have learned about what is mensuration, we have learned basic units and unit conversions, and how to calculate areas of various 2D and 3D figures. Thank you.